Is that like? Okay. Is it showing the whole board right here? Awesome. Thank you. All right, guys. Let me let the music play while I take attendance. If you want to close that door and that door, who wants to pass papers out?
Me! I had my hand up. I was louder.
You start on that side, work in. You start on this side, work in. Give me the ones that you have left over.
I would do that. That's nuts. Somebody smells milk.
All right. Glorious music off. Shh. Zip it. Zip it. Zip it. Thank you. Everyone have a calculator. Make it happen. You should have a calculator. We're doing math. Now, you don't have to use a calculator for this. It can be done. Guys, it can be done by hand. Last year, I think it just so happens, last year, fourth period, angered me by their lack of participation. They wouldn't even put in the comment. Like, oh, okay, you don't want calculators? Fine. I said, put all your calculators up, the few that had them out. And I did that like mass punishment thing where everybody gets punished. And we did one of these by hand. It can be done. Now, if you don't want to do it by hand, then just participate today. It's easy. We're going to, all 5 questions. Guys, shh. You might have to use your computer calculator then, if you didn't come prepared. There's like one right there at your seat. Okay? Shh. So, by the way, you guys know what's going on with gas prices? And you understand why? Okay? I think I just single-handedly brought gas prices down. Guess how I did it? By filling all of my vehicles up yesterday because I thought they were going to continue to go up. So Murphy's Law, if you do something to prevent prices from going up, what will happen to prices? They'll go down. And then I look like a fool because I filled all my gas tanks up. Anyway, we're going to do 5 nearly identical word problems today, guys. If you're talking, I need you to stop. The format for all of them is the same. In other words, for all of them, we are looking for our output in the formula here, which is gravitational force. Every single one of them, all 5, we're looking for gravitational force. Every single one of them, we're given our masses and our distance. And of course, the gravitational constant never changes. So it's always the same. All right, so we're going to have this up here the whole time. All right, I'm going to work at least the first 2 with you. Hopefully you can stay ahead of me. Maybe the first 3, but I am not going to do number 4 and 5 for you or with you. You will, by then, you should have it. So number 1, Kelsey, go ahead and read that for me. Yep.
A satellite with a mass of 800 kilograms is orbiting Earth at a distance of 7.0 times 10 to the power 6 m from Earth's center.
And what's m if we're talking about a distance?
Meters.
Meters. Good. And then it also tells us, go on.
The mass of Earth is 5.97 times 10 to the 24th power kilograms.
Good. And it says, question, go ahead, read it.
What is the gravitational force between Earth and the satellite? Use G equals 6.67 times 10
Okay.
to the negative 11.
Yeah. And a whole bunch of units stacked together. So all we have to do is rewrite our formula, substituting in the actual numbers for the things and the stuff, right? Okay. So first thing is G. What's G? The gravitational constant. What's the value? 6.67 times 10 to the negative 11th, right?
Yeah.
All right, good. Write it down. On your paper, everybody is writing it down. I'm not going to have anyone sitting there waiting for me to do it for them today. Everyone is writing everything down. And hopefully you'll get to the point by like number 2 or 3 that you're ahead of me and stay ahead of me, and then I can totally release you for 4 and 5. All right, so we've got G. What's next in the formula? Mass 1. Should we just use the first mass that's given us as mass 1? Could we use the second mass that's given us as mass 1? It doesn't matter. You can flip them around. It's multiplication. All right, so what's the mass of mass 1? 800 kilograms. Guys, I'm not going to bother writing the kilograms there. Can we agree that we understand it's a mass and it's in kilograms? It's in the word problem. And then we multiply that by mass 2, which is what?
5.975.
And that's the mass of what? Earth in kilograms. Good. Awesome. Is that everything we need for the numerator? It's not. What else do we need for the numerator? It is. It is everything we need for the numerator. We needed the gravitational constant. There it is. We needed the mass of mass 1. There it is. Mass of mass 2. There it is. Okay, we've got the numerator set up. The denominator needs to be the distance between the centers of mass of the two objects, and then we square it, right? And it has to be in meters. If it's in kilometers, it will throw off our numbers. Was this the class yesterday that we came up with like 200 million whatever, and it's supposed to be just 200. It's because we didn't convert first, okay? So it's got to be in meters. Fortunately, today, all of them are given to us in meters. So what is our distance?
7.0 times
And then we do what?
square.
We square it. The humming can stop. Write it. Write it. Write it down. Because we have to square it. Because the formula, question was, why did we write 2? Well, because the formula tells us we have the distance squared. Here's our distance. And to square it, because we got all this other stuff going on, I went ahead and put it in parentheses. You guys understand why I put it in parentheses? It kind of keeps it organized. Otherwise, it'd be like the square root of the 6th. I don't know. Too much. All right. We're only, just for right now, and it's probably a good idea to continue to do this, we're only going to attack the numerator first, okay? I do not have a calculator. All of my calculators are out with you all. That's okay. I trust your ability to input numbers, but if you get it wrong, don't freak out. It's probably just a single-digit error, okay? Put it in exactly as I say. 6.67 times 10 caret. The little caret symbol gives you the powers, right? It gives you, the caret, the exponent symbol is all the way on the left, halfway up. Yes, the up arrow looking thing. So it'll be 6.67 times 10, up arrow, the caret, negative 11. The negative sign is down by the equals button. No. No. I'm telling you. You understand? I am telling you right now. Don't even interrupt me unless you like have an actual question. So 6.67 times 10 to the negative 11th times 800 times 5.97 times 10 caret 24. Now hit enter.
Can I say what I got?
Syntax error, you put something in wrong. You hit a button wrong. What'd you get?
I got 3.18592 times 10.
Slow it down. 3.18
5, 5, 9, 2, 10, a little 17.
times 10 to the 17th.
Yeah.
All right. Put it back in and let me know if you still have a problem. I'll come over and I'll probably be able to find what you did wrong. You got it. Okay. So what did I say? I said it is easy to make a mistake if you just hit one wrong thing. It can throw the whole thing off. All right. Raise your hand if you did not get that as your answer for the numerator. So everybody has that for the numerator. Fantastic. This is just the numerator right now. This is the answer for the numerator. But then we're supposed to divide the product of those three factors by the square of the distance. So I'm just bringing this down. I'm not changing it. I'm just bringing it down. So if you still have this in your calculator, just hit divide. And it'll probably say answer divided by, right?
Yep.
And then you're going to put in 7. Oh, do an open parentheses. Put it in parentheses in the calculator. So it'll be divided by open parentheses 7 times 10 caret 6 close parentheses caret 2. Then hit enter. I do want the answer, and I'll take it from you, Coach. Go ahead.
6501.
And I'm going to round it to just right there. And that's going to be in what?
Newton.
Because we're talking about gravitational force. What do you got? Yes. All right. Shh. So, yes. Okay, let me check your calculator. Oh, you got a different calculator. I hate when students have different calculators.
I'm sorry.
How dare you?
I'm sorry.
Is it because I put the little square thingy up there?
Then, so,
I'm like really, I don't know how I put it.
So you multiplied
Was
them.
it like?
No, you multiplied them.
Oh shoot!
You need to divide them. Call me over if you need me to check it.
Mine's different too.
Okay.
I think this is the right button, but I keep getting a different answer every time I get a different answer from what the class tells me.
You need to. If it had the container, it would have the instructions on how to use this. Google how to use that. Like how to get exponents. Yes. He asked me if I wanted to, and then he didn't. I said yes, and then he didn't.
I just sent him a text because we had like 6 buses going out here. So I
Yeah.
just sent him a text. I said, "Do you need me to drive them over and drop them off?" He said, "Ike originally said he could,
Yeah,
so you're good."
I still can. I'm waiting for him to say you got it.
All right, you got it.
All right. Okay. Shh. Anybody else need me to take a look at their calculator? Maybe you have a goofy calculator. I just told McManaway, hey, you better Google that and figure out how to use it because it doesn't have the same symbol to get to exponents. You guys understand? These are exponents, right? The power of 17 in this case. You've got to know how to access that. So for the standard calculator we've been using, it's the little caret symbol, but yours might look different. If you don't know how to use it, Google your model calculator, ask it how to get to exponents. All right. So I'm going to walk through, before we move on to number 2, I'm going to go step by step of what we did, and you are going to ask me, wait, why? Or I got something different. Okay? Okay. So first off, we read the question. the question asked, remember I told you need to think of two things. What is the question asking for? It's asking for a gravitational force, yes? And then I also tell you to look at what you are given. For number one, we were given the gravitational constant, we were given mass 1, we were given mass 2, and we were given the distance. Yes? So we know this is the right formula. This is the formula we're going to use all day, or all class. So we write the formula, and then we replace the variables we're given. So the g, which goes here, we replace it with the value. Mass 1 goes here, we replace it with the value. Mass 2 goes here, we replace it with the value given to us. And then we have the distance here, we're given that. Plug it in. We went ahead and worked out the numerator first. The reason I did that is because that's a whole lot of typing in the calculator, yes? If you make a mistake, like here, and you don't have this number written down, what would you have to do? Wouldn't you have to go back up here and type it all in again? So basically, by writing it here, we just lock it in so that if we lose it, we don't have to write all of this. We could just write this. Okay, and then you divide the numerator by the denominator, which is the square of the distance, and we have to put it in parentheses and then square it. Another class, first period. I had a student that worked out this first. Guys, are you paying attention? We're just telling stories over here. What? Playing with our pencils? Okay. I had a student that worked out that she squared this first, and then she divided down. It should have given her the correct answer doing it that way. It did not. What it ended up doing, not on this question, but another question, is it added when you divide with scientific notation, you're supposed to subtract the exponents. It added. So my calculator and hers did that wrong if you squared this first. You don't have to do that. Just go ahead and divide down with it formatted this way. It shouldn't matter, but for whatever reason, our calculators, it did matter. Okay, so just do it the way we're doing it right here. It's probably a setting in the calculator. I don't know. All right, are we good on this one? So we just divide. So we multiply across the numerator, divide down. We should end up with that. Did anyone not end up with 6,501 newtons? Okay. All right, so now let's put it in perspective. That means that is the satellite pulling on the Earth with that many newtons of force, or is the Earth pulling on the satellite with that many newtons of force? The Earth is pulling on the satellite?
Yeah. No.
Yeah.
Well, what is it? Which one is it? It's a trick question. It's both. Who said both? Good job. That gravitational force, guys, would it have mattered if we put in Earth first or satellite second, or satellite first and Earth second? It wouldn't matter. So if that doesn't matter, then doesn't that gravitational force get applied equally to both of the masses? Yes. Yes. The satellite is pulling on the Earth with 6,501 newtons of force, just as the Earth is pulling on. But the acceleration is different, right? Because which one has way more mass? Good. All right, are we clear as can be on number one? All right. Moving on to number two. You guys go ahead and get started. I want you to stay ahead of me. Go ahead and start plugging in the values for number two. All right, number two. We've got two asteroids. Are you going to write it down? Did you already get it? For number two? Yeah, did you already do it?
Yeah.
Oh, okay. You're already through the whole thing?
Yeah. I don't think I got the wrong one.
Okay. So you're waiting for confirmation. Awesome. That's good. All right, here we go. 2 satellites in space have masses of 4 times 10 to the 12th kilograms and 7 times 10 to the 12th kilograms. They are 2 times 10 to the 4th meters apart. So they're actually relatively close to each other, traveling through space. Okay. What are we looking for? It says, what is the gravitational force between the asteroids? We are looking for gravitational force between those 2 asteroids. So we have it set up the right way. We're not going to do any rearranging today. What is the first thing we put in our numerator? Could we put M2 first? I mean, if you want to be consistent, we'll just keep doing gravitational constant. But I want to drive home the point that you can put any of those 3 things that are in the numerator in the formula. It doesn't matter the order you put them in. But yes, we put the constant in, so 6.67 times 10 to the negative 11. I'm bringing it back, y'all. Oh, it's so nice when the shoe's on the other foot. All right, and we're going to put it in parentheses. Put one of the masses. Does it matter which mass? No. Somebody give me one of the masses. What was it? Somebody give me one of the masses. 4. So 4 times 10 to the 12th? And then the other one was 2 times 10 to the 12th.
It's 7. It's not 2.
Do I need to look?
It's 7.
It's 7. Okay. And then we'll close that off. There's your numerator. The denominator. What is the distance between the asteroids? 2 times 10 to the 4th. And then we put it in parentheses and we square it. That is your setup. Again, we have the constant, gravitational constant, times the 2 masses divided by the distance between them squared. Could you multiply across and divide down all in one step on your calculator?
Yeah.
Depending on the calculator, yeah, you could probably do that. I don't care. I want us to lock in the numerator value first. What did you get? Which one's wrong? Is it 12?
Yeah.
Sorry. Thank you for catching that. So go ahead and, I don't have a calculator. I'm not doing it for you. She's going to give it to me. Go ahead.
Well, I can't solve over to 806. It's either 1.8.
Put it in the calculator again to confirm. Is it a bad idea to run the numbers twice?
No.
Is it a bad idea to run the numbers 3 times? Is it a bad idea to run the numbers 4 times? If you got the same number 3 times, at some point it starts being a bad idea. You're just wasting time. It's up to you how many times you double check. So somebody give me that numerator value. You have it?
Yeah.
What is it?
1.8676.
Is that what everybody got for the numerator?
Yeah.
1.8676 times 10 to the 15th. Everybody got that for number 2, the numerator. Cool. And then the denominator, we just drop that down. We keep it the same for this step here. Just rewrite it. And now we've got it kind of recorded, locked down. If we lose it, we don't have to do the whole thing again. But if it's still in your calculator, just hit divided by and put in parentheses 2 times 10 to the 4th, close parentheses, and then square it. So caret 2, or whatever your symbol is on your calculator.
Vivian got it right. I got it wrong. Because I've got the parentheses in the square.
So you already caught your mistake.
Yeah.
And you already fixed it.
Yeah, Vivian got it right.
So redo it in your calculator. Make sure you get it.
Oh, I did.
Okay. All right, so what did we get? Who do I want to pick on? Who wants to volunteer? Go ahead.
4,000. Or let's do 4,669. Yes.
That's wrong.
Is that wrong? The numbers look good, but we're missing what? We're missing 3 zeros.
Last time.
Yeah, we're not rounding tens and hundreds and thousands off. So you're telling me it's 4.669 million newtons. Yep.
Yeah.
There's no point. I just changed it to millions, right?
Okay.
So you can read this, guys. If you weren't aware, it's been a while maybe since you did this in math. You can read this as 4,669,000, or you can read it as 4.669 million newtons. It's the same thing. All right. Shh. Call me over right now. Raise your hand if you did not get that for an answer. They're both just using a formula. We're being more deliberate today, doing the same one repetitively over and over again. All right. Shh. Yes. So we've done the first two.
We're doing by ourselves.
Are you after 2 ready to release? All right, do 3, 4, and 5 on your own. Go. On number 3.
I'm getting like to the power for the.
Mm-hmm.
Is that certain? Or did I just do it wrong?
That's correct. I'm pretty sure that's correct.
So I'm supposed to get like to the power?
Yes, because this is a really big number, so they're keeping it in scientific notation. Because it's the Earth and the Moon. They're extremely massive. So your gravitational force is going to be a really big number. Yep. Hey guys, when you do the Earth and the Moon, if you get a really big number, don't rule it out just because of that. It is going to be a big number. The Earth is quite massive, and so is the Moon. That gravitational force, even though they're like 250,000 miles away from each other, it stays big. Yes. Yep. You next?
I was just wondering if we're still using the 6.67.
Yes, the 6.67 times 10 to the negative 11th is a what? A constant. It will always be that number for gravitational constant. What do you got?
I just don't know how to put it. I just don't know how to make
Just like that. So for all 5 of these, you're going to use the same formula. We're looking to solve this. You're going to put in the gravitational constant here. So the first thing, doesn't matter, it hadn't had to be the first thing, but you put that in. You also put the mass of one of the objects, and then you put the mass of the other object. And then in the beneath the denominator, you're going to have the distance in parentheses, and then square it. Yep. Let me see. You got that. You got that. You got that. And you put that down there. And you squared it. Yes, that is your setup. Yes, and you're working on that one, right? This is right. This one, you got the constant, and you got the 2 masses. Yep.
6.7 times 10.
What's the question?
It puts E at the end.
Yes, that's the scientific notation.
So good. It's like
That's its way of saying times 10 to the. Hey guys, if you have a calculator, or the computer that says E something, the E is the times 10. That's their symbol for scientific notation. So that number after is basically times 10 to the, that's the E, and then the number after is the power you raise it to. It's a big number for number 3, yes. Who had me next? Was there somebody over here? Yeah. Hold on, I got him first. Yes, that's correct.
I was thinking, do I write this or do I?
No, that's exactly how I would want you to write it. Because if you didn't have it in scientific notation, there'd be a whole bunch more zeros.
So do I still need to write the N right here?
Yes. Hold on, you're next.
Why are there so many things?
It's repeating. You can round it back, so like just to 8, 9, because 3 is less than 5, right? That's it. That's the answer. You can absolutely. Several of you have just called me over to check your work. That's fine. Yep.
I think I did it wrong.
Because I got 5 point like something.
Yep, that's wrong.
So what do I do? Because Vivian did something wrong too, but we don't know what we did.
Okay.
That's a lot of zeros.
You didn't square it. You got to put your denominator in parentheses and then square it.
Did I do it right? Not that one though.
This one times 10 to the 42nd?
Probably. Yeah.
Probably not.
Wait, is this one? But it's like.
That
on the
looks
bottom-
right.
On the bottom, it's a bunch of zeros and a 9.
Your quotient is.
Can I pocket this when I come back to this one?
Sure. So this is your numerator.
Wait, 3, 6, 8.
What?
4, 5, 6, 7, 8.
Check it. What am I checking? 3? Yep. You divide it by the square of the distance. But you don't have to. Hey, you don't have to square the distance first. You take the numerator, that 0.02, whatever it is, divided by, in parentheses, the distance, and then squared. Huge.
Oh yeah. So do I do times 10 plus
What that means right there is times 10 to the 32nd or 37th.
Yeah, plus
Yep.
37?
No, not plus. It's a positive. That's a positive sign. This right here is just a positive sign. They're saying this is times 10 to the 37th.
But they do the tiny numbers. They're able to do the tiny numbers.
Yeah, in here you inputted that. They're outputting it with an E.
Oh, so I can like I did the tiny
The E means the same as times 10.
and that's super tiny number.
And then the 37 is the tiny number up top.
Does this look great? And then I'll get what you think.
Yeah.
a long number?
Yep. Now you need to do the math to get the answer. Hold on. You're missing the rest of your scientific notation here, because it's that, I think, times 10 to the 20th. I want to say. Yep. I'll have to do this one. I forget. I don't think that's right, but I'll check it. And then that one looks right. Okay, this one's right. I'm not sure about that one. Oh, that is right. You just have it in scientific notation. My calculator didn't do it in scientific notation.
Should the answer be a big number?
Yes, for number 3, it's a very big number.
So
That
if
is
it's a
correct.
point, does that mean I should round it if there's a point now?
If you want to.
Can I have your paper? What? No.
I'm gonna do all of them on the board.
I didn't do the second part of it, but I still got the same answer as Joel. I just told you.
Yeah, you probably just did it all at once.
Yeah, I just talked it all.
You typed all that and divided by that on one
So
step.
I can just do that
You
all
can
the
do
time?
that. Yes.
I don't need to do that stuff ever.
You are doing it. You're just not showing it.
Oh, so I can just keep doing this.
You can.
Thank you.
It's just if you make a mistake, you'll have to start all the way at the beginning.
Is there hands?
Yes.
This looks wrong. This looks wrong.
Well, the number is right, but you're missing the scientific notation. You can't ignore that. No, that's not scientific notation. Put it back in the calculator. Do it again, and actually write down what it gives you as the answer. Yes. What? If that was part of the answer, you can't get rid of it unless you convert it out of scientific notation. Hey, listen up. Shh. Listen up, guys. Shh. It's very important when you're answering these questions. If you do the whole process right, and your calculator spits out a response, and it has scientific notation. So your answer says a number times 10 to the something. That is the answer. You can't just not write the times 10 to the something. If you don't want to have it in scientific notation, you'd have to convert it out if you remember how to do that from earlier this year. If it says a number and then E plus or minus another number, that's the equivalent of times 10 to the whatever power. It's the same thing. It's just your calculator is formatted differently. You can't just not put that. You have to include that. Yeah. Yeah, you're probably skipping rewriting this, and then you probably just went straight across and then divided down. You can do that. What didn't I tell you? We're not going to do it. We're going to write it down. So if you had to redo it, you don't have to go all the way back up here and type all this in again. You'd only have to type in that again. This is that. But it's shorter because it's already been worked. But if you're just doing this, you'll still get to the right answer.
Me and Vivian both got this answer. Is this right? Or did we both do the same thing? Well, no, that's
That's correct.
It's right here.
That's correct. In newtons.
Okay,
N.
so is that like
Why is
the
that?
final
Why is that an
answer?
H?
That's an N.
That's an
Is
H.
this the final answer?
Yeah. In
It's
newtons.
still in a.
It's not in scientific notation. That's the actual number.
But that's it in scientific notation.
No, that's not.
Okay, so what do I do?
I don't know what that is.
That was.
What's up?
Final.
Yes.
So proud of you.
How do I
You helped me.
like put like 10 to the
Okay, number
11th
three.
hour?
I got number 4 right.
I don't know. Is it? Is that the one?
So I type in
Get
10.
10. And then, yes, and now you can type it in.
All right, thank you.
Yep. Make sure it's a negative 11.
Oh yeah.
Yeah, I just typed it in.
All right, is everybody ready for me to work number 3?
You do number 4 first.
No, I'm going to do them in order. All right, so if you don't mind, I'm going to leave the constant there because it's the constant. Is that fair? I think we've established that. That is not going to change. So for number 3, we have the Earth and the Moon. We are given the Earth's mass. We're given the Moon's mass. We're given their average distance from each other, their centers of mass. And we're asked, what's the gravitational force between them? So M1, do you want to make Earth M1? Yeah. Okay, so that's 5.97 times 10 to the 24th, right? I think I have it memorized. Still working on the Moon, that's 7.35 times 10 to the 22nd, correct? All right, I'm getting there on the Moon. I'm almost got it memorized again. Every year I re-memorize it and then I forget it again. Shh. Good. All right. The distance between them is 3.84 times 10 to the 8th. To the 8th. No, the distance from the average distance from Earth to the Moon is just this. But for our formula, we need to square it. Calm down. Is there a problem?
Yes, he keeps calling me.
Do I need to send you guys to the daggone administrators? Is it nice? Do you want her to call you a similar equivalent? Okay. Because it's been going on for weeks. She's sick of it. I'm sick of it. Everybody's sick of it. Can we agree? Okay. What?
Isn't it 5.97 times 10?
Ah, yes. That's twice you guys have caught me. That's good. I'm doing it on purpose to keep you on your toes. Am I allowed to make mistakes sometimes? Okay. Because it's going to happen, whether you're allowed or not. Shh. All right. Yes, I'm glad you double checked me. This is our setup. So I'm going to walk you through it again. We're looking for gravitational force. Here's our capital G, the gravitational constant. Here's mass of Earth. Here's mass of Moon. And we're going to divide it by the distance between them. And then we're going to square it. Guys, yes, you can multiply across and divide down in one step and get the answer. For class, we're doing the numerator first writing just the product of the numerator, rewriting the denominator, and then doing it. Why? Because if you screw up, you've already got the product of the numerator down. You don't have to go all the way to the beginning. It's not that big a deal, but that's the way we've been doing it. Oh, look, I do have a calculator. Unless somebody just put that there. But did you put that there? Okay. I just missed it. All right. So let's put in 6.67 times 10 caret negative 11, so to the 11th power, times 5.97 times 10 caret to the 24th power times 7.35 times 10 to the 22nd power equals. So we lock in our numerator. Correct me if you got something different. 2.9267625 times 10 to the 37th. Okay. And then I just rewrite this. I'm going to keep it 3.84 times 10 to the 8th squared. Now I'm going to put that in the calculator. So I still have my numerator in the calculator. I'm going to divide by open parentheses 3.84 times 10 to the 8th power close parentheses and then square it. And I get 1.98. And I could write the whole thing out. I'm going to round to the hundredths. So it'd be times 10 to the 20th. Newtons. Why newtons?
Oh, I forgot there's no weight.
Because it's a gravitational force. And we measure force in newtons. All right. Shh. Doesn't 4 come after 3? So yes, I will do 4 next. Questions on number 3 first. We'll have to do number 4 fast if we're going to get it done today. Shh. Calm down. Calm down. Well, we can do 5 tomorrow. That's fine. Last class didn't get to 5 yet today either. All right. Shh. Ready to do 4 as fast as we can?
Yes.
All right. Could we stop the tapping? Thank you. All right, guys. For expediency, since we only have about 3.5 minutes, I'm going to do it all in one step, which is the way a lot of you prefer because you're lazy. Yes? Is it? Am I telling a lie?
No.
Okay. All right. So don't get all offended if it's true. Shh. We will. Perhaps. We'll see. You guys have been participating today. I like it. All right, we got 2 spacecraft traveling in deep space. One spacecraft has a mass of 1,200 kilograms. Boom, there's our first mass. The other one has a mass of 2,500 kilograms. I'm not putting the kilograms. Don't hate me. All right, so we're done up there.
Yes.
The distance between them, shush, it's 150 meters. And then we square it, right?
Yes.
I wouldn't need the parentheses there, would I? No. All right, let's just type it in. So we have 6.67 times 10 to the negative 11th times 1,200 times 2,500 divided by 150 squared. Now, I get, it should have been the same even if you had parentheses. So I got 0.00000009
Yes.
newtons. That's point with 8 zeros and a 9. If you got, what was it? How did it say? 8.89. If you got this, it's the same thing. This rounds to 9, doesn't it? So this is the scientific notation answer. This is the like slightly rounded, not scientific notation answer. How you guys feel about that? Better?
I understand it.
We'll double check it tomorrow. Come here, you. Away we go. Number 1. By the way, I'm going to leave some things on the board because they're going to stay the same the whole time. Guys, what's the one thing in that formula that stays the same no matter what? The gravitational constant. So I'm going to leave it right there. And we're going to do it 2 different ways, but really they're the same way broken down. Does that make sense? If it doesn't, it will. So we have our gravitational constant in the formula, or it already plugged in. The formula says to get gravitational force, we multiply the gravitational constant by the mass of the 2 objects. And then we divide that by the square of the distance between the 2 objects. So for number 1, let's read. We have a satellite with a mass of 800 kilograms, and it's orbiting Earth at a distance of 7 times 10 to the 6 meters from Earth's center. Remember, we're supposed to use the center of mass. The mass of Earth, we're told, is 5.97 times 10 to the 24th kilograms. The question is, what's the gravitational force between the Earth and the satellite? And we're reminded what the constant is. We already have it up there. Yes, there's letters that go after it. We're actually going to leave those out. We know we're going to be looking for what as an answer? So what would the unit be? Newtons. Good. So I'm going to switch to orange. So we'll leave those the same, but we'll do orange for the things we change. What was the mass of the satellite? 800 kilograms. Okay, 800 kilograms. The mass of Earth is 5.97 times 10 to the 24th, right? Kilograms. Yes? Yes? Okay. I need you to write it down. There's space on the paper for you to write this stuff down. I need everyone to participate. On the first one, we can work it together. On the second one, hopefully you'll already be trying to stay ahead of me. And then then we'll see where we are. We might be able to do 3, 4, and 5 completely on your own, and then I'll just go over them. What was our distance between the satellite and the Earth? No, that was the mass of Earth. Hold on. What was it?
7.0 times 10.
And then we need the square, right? Notice I put the distance in parentheses just so we don't get this all running together. And when we put it in the calculator, we need to have the denominator in the parentheses. We don't need any of this up here in in parentheses. I just did that for organization. All right, so right now, the first time through at least, we're going to do the numerator first. So go ahead and multiply across, and then I'll ask for what you got as a product for the numerator. Go ahead. Take the top 3 numbers across the top, the numerators. Take that times that times that. Do you need me to tell you how to input it in the calculator? I can do that. All right, so in your calculator, if you have a standard calculator, like you do, pick it up. You have to have it in your hand. I mean, I guess you could poke at it on the table. That's fine too. Put it in exactly as I say it. 6.67 times 10. And then do you guys see the little caret? It's called the caret. It's an up arrow on the far left, midway up. Do you guys see that? That's your access to exponents. It's the powers button, right? So you have 6.67 times 10 caret negative 11 times 800 times 5.97 times 10 caret 24. Hit enter.
It says 3.1855.
All right, Grant and Grant only. Go ahead.
3.1385592 times 10 to the power 7.
All right. Shh. Now, if you got an error, I need you to go back and do it again. Make sure you put it in exactly as I say. If it happens again, I will come to you and see what you put in wrong. So, clear, clear, clear. Clear, clear, clear. And everybody's going to do it because we're going to double check this number. All right, so 6.67 times 10, caret symbol, negative 11, times 800, times 5.97, times 10, caret symbol, 24, enter. Raise your hand if you get an error message again. I will come over to you. Does everyone get 3.18 ... times 10 to the 17th? Sweet. Did anyone in their calculator or computer not have times 10, 17, but it says E17? E is your machine's way of saying times 10. Does that make sense? All right, very good. It would say E17, or it might even say E plus 17. It's just giving you the symbol on this. It's a positive number. Huh? This is the answer to that multiplication problem. So just the numerator, we multiplied those three factors together. This is the product. Okay? This is the product of all three of these multiplied together. Yes, I can. I'll read it. This is the third time. I'll read it again. 6.6. It's on your paper. Oh, yeah. It's 3.18. But you probably have it on your calculator, don't you? You erased it already? Okay. So I got 3.185592 times 10 to the 17th. All right. Now, get that back in your calculator if you lost it. But that's why we wrote it down, too. If we lose it, we don't have to type all this back in. We've got it. Exactly. Exactly. And then we're going to rewrite our denominator. 7 times 10 to the 6th squared. All right, so in your calculator, either type this, or if it's already there, just leave it and hit divided by. And most of your calculators will say ANS for answer, right? Slash for divide. And you're going to put it in exactly as I say it. Parentheses, open parentheses, 7 times 10, caret 6, close parentheses, caret 2. I have had people having trouble if they're doing the squared button. Don't do the squared button. Do caret 2. Caret 2. Yes, I will. You are dividing our previous answer, which is the numerator. You're going to divide that by open parentheses, 7 times 10, caret 6, so to the 6th power, close parentheses, caret 2. So your machine might be different, but we're raising it to whatever power. In this case, we're doing it to the 6th power inside and the 2nd power outside. Everybody good on that? Hit enter. What do you get?
6,501.208.
All right, stop. We're gonna round to the nearest whole. So you should end up with 6,501 newtons. If you did not get that, call me over right now. I want to see what happened. You see? Okay, so you had it by 2 on the inside. It's not supposed to be. So the caret is right here. A little up arrow. Yep, use that one instead.
So,
Yes, you got that right.
I'm asking about that. So you add all this together.
You multiply.
Oh, yeah, multiply. And you get that. But
Yep.
how do you get the 10 to the 17?
It gives it to you. See how it gave it to you right there, the E17? That means times 10 to the 17.
I
Yep.
see that.
Yep.
All right.
That's it. All right. Anybody else? Those were easy. I love it. All right. Any questions on the first one? Hey, you know what? Before we move on, before I erase it, I'm just going to say what everything is again to kind of lock it in. All right? So we had our formula over here, and all we did is basically rewrite it with the information we were given in. We were reminded what the gravitational constant is. So capital G, it's right here. The mass of object 1 right there, and mass of object 2 right there. Could I rearrange any of these three?
Yes.
Yeah, because we're multiplying them together, so they can be in any order. Doesn't matter. It's probably best practice. Could you agree? Maybe that if we just do it always the same way, that kind of just keeps things simple, right? The first mass that's mentioned to us in the word problem, just put that as M1. Okay, and put constant up front. And then we were given the distance. We put that in parentheses in the denominator and squared it. And then for this first problem, we just did the numerator, put the product of the numerator here, and then rewrote the denominator. And then we solved. Going forward, if you prefer, you can absolutely do it all in one step. You could multiply across, and then you can hit enter and then immediately go to divide. Or you can actually multiply across, hit divide by, and put that in. Should work the same. Questions on that? Everybody understand? Okay. All right, now one last thing. So this is a satellite, the 800 kilograms, orbiting the Earth. Way, 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 way more massive, yes? Okay. So our answer is gravitational force is equal to 6,501 newtons. Is that the force that the satellite is pulling on the Earth with gravitationally, or is that the force that the Earth is pulling on the satellite with gravitationally? What? It's both. Good. Yes. There was no hesitation. He's like, it's both. So the way I phrased that question was like a trick question, but you read right through it. Fantastic. You guys understand? Because they're in that numerator together, and you could flip them around. Your answer applies to both. Okay. Let me erase. Number 2. Does anybody want me to go ahead and do it with you, or you guys want to get a head start? All right, get a head start. Try to stay ahead of me. If you can't get far ahead of me, that's okay. I'll be right behind you. And you can let me catch up and then try to get ahead of me again. Does that make sense? Is that thing still recording?
Yeah.
Okay, good. I heard a...
It should be red, right?
Yeah. Okay. It would. I guess the screen would have turned off by now if it wasn't recording. So what 2 things do I put next to gravitational constant in the numerator? Go. I put the masses of the objects, right? So I'm going to have a mass there. I'm going to have a mass there. I guess I could read the question. We've got 2 asteroids. Shh. You're working it. You're working it? Okay. Oh, there could, if you get any minor detail wrong, it will flip it. Okay? It will change it. So we've got 2 asteroids, and we're told that they have a mass of 4 times 10 to the 12th. One of them does. And the other has a mass 7 times 10 to the 12th. And of course, they're in kilograms. And I'm going to use, guys, real quick, I'm going to rephrase how I say this. The mass is 4 times 10 to the 12th kilograms. It's kind of weird to think about. So I want to visualize this for you. if this is 4, and I want to convert out of scientific notation, how many places do I need to move the decimal point? 12. So there'd be a comma here, 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 and here. So this would be hundreds, thousands, millions, trillions. 4 trillion. So instead of saying 4 times 10 to the 12th kilograms, I think it's worthwhile to put it in perspective. This is 4 trillion kilograms. This asteroid is 7 trillion kilograms, almost twice as much.
Is it more than the Earth?
No, they're asteroids. So it's a big number, but it's still relatively small.
Oh, so they're pretty light?
Yep. Well, it's the mass. It's not a weight. All right. Shh. So we've got that in perspective. So 4 trillion and 7 trillion. What?
So like, once you get the product of this,
Then you divide it by the denominator.
yeah, you put the 2 after all this.
Yeah, you're going to put your...
After the
Correct.
times
Not times.
the thing.
The caret. Yep. Yep. All right. Shh. A lot of extra talking. I'm pretty sure it's not on topic. All right. So then our distance, what was our distance? Okay. And then we need to square that. All right. So for this one, for number 2, dare we just do it all in once? Okay. So again, I don't have a calculator on me. So I'm going to read it off. If you haven't put it in yet, put it in exactly as I say it. And then I guess everybody else is just waiting to see if you get the same answer. So here we go. Double check your own work if you already got it done. 7.67 times 10 caret negative 11 times 4 times 10 caret 12 times 7 times 10 caret 12. You can hit enter if you'd like, and then you're going to divide by open parentheses 2 times 10 caret 4 close parentheses caret 2. Enter. Buckman, you have it? What'd you get?
9.33 times the power of 10.
Times 10 to the power 10? Let me take a look. That does not sound right.
Yeah, I got
Okay. I just said I didn't get that either. So I'm gonna investigate. Kind of. Oh, we didn't square it. Try squaring it. So right now type in caret 2 and then hit enter and see if we get something different.
So number 233.45.
It's like 1.8 for function of something.
So I'm gonna go all the way to the top, start from the beginning. So the numerator, you got that, right? Okay. We're going to divide, open parentheses, 2 times 10 to the 4th, close parentheses, squared. Did you guys get 7.96? That's what it should be. It should be 4.6 million. Shh, let me type it in again. Something's going wrong here. 6.67 times 10 to the negative 11 times, wait, why did you have 800? times 4 times 10. Yeah, you had numbers in from the last question. Yep, that's what it was. So times 10 to the 12th times 7 times 10 to the 12th. There we go. And then we're going to divide that by open parentheses 2 times 10 to the 4th, close parentheses to the 2nd. There it is. All right. Shh. So we got, so somehow when I looked back up, she still had the 800 kilograms as one of the masses from the last one. So we were like mix and matching between the two. So we ended up with 4, what was it, 4, 6?
6900.
Okay. So if you put our commas in there, that's going to be in newtons. That's 4,669,000. Or you could say it absolutely as 4.669 million. That make sense? That is the answer. To number 2. You're done. Yep. Did you not get that?
Oh, I did.
You did. Awesome. Yep. Wait, I thought you said you got it right.
I said I got it wrong.
Oh, okay. Show him when he gets back. Okay. All right. Questions on number 2. All right. You're off to the races. Go ahead and do number 3, 4, and 5. On your. Well, I'm asking you to. Do I need to like? You must. It's an assignment. I mean, it is an assignment, right? Yes, you guys are doing 3, 4, and 5. If you have a question, ask me. We're going to work 3, 4, and 5 now on the board. I'm going to ask you guys for the answers as we go, and I'll confirm if you're right. Dexter's talking. I'm glad you're done, and I already confirmed that you guys have them right. There's a couple people still working. Let's go. So for number 3, yeah, let's go. Number 3, the Earth and the Moon. Mass of Earth is that. The mass of the Moon is that. Distance is that. So let's just plug them in. We have the constant up there already. Earth's mass first. 5.97 times 10 to the 24th times the mass of the Moon, 7.35 times 10 to the 22nd kilograms for both. And we're going to multiply straight across, making sure we don't make any boo-boos. And then we're going to divide that answer. So we go multiply across, hit enter. It'll give you the answer for the top. And then we're going to divide by the distance, which is 3.84 times 10 to the 8th meters. We're going to put that in parentheses and we're going to square it because that's what the daggone formula tells us to do. So multiply across, divide down. What do we get? Number 3.
1.947937952 times 10 to the 20th.
That's it. Now, would I mind if you cut that all the way back to 1.98 for this class? No, you still got to make sure you keep the times 10 to the 20th there, okay? Okay, and what would our unit be? Newtons, because we're talking about gravitational force. Wait, is everybody good on that? Number 3? I think everybody had finished 3. So for, oh my heavens, a lot of extra conversations. You guys. Now number 4 and 5, I think I still have a couple of people working. So this will be live for you. Number 4 says we have 2 spacecraft traveling in deep space. One spacecraft has a mass of 1,200 kilograms, the other 2,500 kilograms. They're separated by 150 meters. Are you okay? So we have 1,200 and 2,500 kilograms. You're still working. I don't know what you're talking to him about. Do I need to wait on you? Yeah, I'm on 4. So we're on the same problems. We're doing it live. Why are you talking to him? Come on, let's work it. So we've got our masses. We've got our distance is 150 meters. And we got to square it. You got it written down? Good. All right, so now multiply across the top and divide down. And you can give me the answer when you get it. Got it? Remember, these are 2 spacecraft. There's not a whole lot of mass there. 1,200 kilograms and 2,500 kilograms ain't a whole lot. What? Hold on, I can't hear you because I got this conversation going on over here. I'm about to write somebody up just to make a show. 0 point what? Wasn't it this?
Yeah.
Okay. All right, so double check it. Have your neighbor help you. Okay. So this is the correct answer. In newtons, right? Is that a big number?
Yeah.
It is an extremely small number of newtons. It's way less than a whole newton. It's a tiny fraction of a newton. You would not be able to notice this just with your senses. But that makes sense because we're dealing with tiny little spacecraft. Does that make sense? Tiny little spacecraft. Now, how many of you all had a very different looking answer? Go ahead and give it to me.
8.89.
All right, so, and then times what? All right. That's the same answer. Do you believe me?
Yes.
Do I need to prove it to anybody? Really?
I believe you.
Because times 10 to the negative 9th, wouldn't I be taking this decimal and going 9 places? So we got zeros. And then wouldn't somebody probably say, you know what, we could round this to 9? It's the same. Okay? Good. Why are we putting our papers away? We have 30 seconds. I'm just kidding. We can do number 5 when we come to class tomorrow. Make you suffer?
No, make me suffer.
You said you want me to do a test and make you suffer.
What are we doing?